All right. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi
Waalaikumsalam
wabarakatuh.
warahmatullahi wabarakatuh.
Good afternoon, guys. How are you? Hello, can you hear me?
Yes, sir.
How are you today?
Yes, sir.
Are you good?
Yes, sir.
Good, sir.
How was it, your midterm? Is it okay? I see you're smiling. It means it's okay. Did you learn your score? No or yes? Do you know your score? Is that score is directly can be known after you finish your exam or not?
No, sir.
No. So it is not directly in your screen when you finish your task.
Yes.
Okay. So you didn't know your score. Okay. Hopefully in a couple of days, you are going to report your midterm test result to your parents. At that time, you will learn your score. But I think everybody have already know whether you're doing well or not good in the midterm task. That's not the problem. That's just on the task. You will have many tasks again in the future. So what should we do is after we finish the task, we look at ourselves. What have we done before the task? Do we study well? Do we understand well? Or do we have maximum effort to prepare ourselves for the midterm? That's important. After that, you will look at yourself. The best thing for you is to improve yourself after the midterm. So that's why now it is the first lesson after the midterm. So I hope you will improve yourself better than the thing that we done before the midterm. Okay, so this is a new lesson after the midterm. So let's start the lesson by praying. Before we start, let's pray. Pray begin. Amen. Okay, so brand new topic we are going to learn today after we finish the electronic configuration. The next thing that we're going to see is about the periodic table. In some of the thing, electronic configuration have a connection with the periodic table. So that's why please don't forget the thing that you learned before, especially about the electronic configuration, finding the electronic configuration of each element. So you have to remember that one because we're going to use that knowledge in study about the periodic table. Okay, don't forget to fill your attendance, please, as usual. I'm going to share my screen before we start, and please you fill in the attendance. I'm trying my new camera here. I don't know whether it is will be working or not. So I'm trying new things here. So if I'm using the camera outside the computer and I make the camera stay on, what will happen? Can I write in the presentation or not? I'm going to try now. If it is okay, I can write, then it's good. So I can turn on my camera, but if it's not okay, then I have to find another way to keep my camera on at the same time I can write in my presentation. So this is the thing I try. Hopefully it will be working. So I'm not going to turn off my camera. Let's see whether I can write or not. Okay, our topic today we are going to see now it is chemistry lesson 24, guys. We already came to chemistry lesson 24. This is a video conference, and chemistry lesson 25 will be in the WhatsApp. Today we're going to study again in the WhatsApp, like the last lesson we did in chemistry lesson 25 and in the afternoon. Okay, in this lesson 24, we're going to see history of the periodic table. Actually, we're going to see the history of the periodic table. Now, there have been a discussion about the history lesson. Did you follow the discussion in the news about the history lesson? Anybody knows? You don't know. You didn't.
I know, sir.
Yang
What happened to the history lesson?
can I speak bahasa, sir?
Yes. Yes.
In the new di berita kalau nggak salah itu sejarah bukan bukan mata pelajaran wajib.
So they're going to erase history in the curriculum. It is news that viral in a couple of days, but the ministry say that it is a hot news. You heard about it, maybe? Yeah, our Minister of Education, Mr. Nadim, said that it is a hot news. We are not planning to erase the history lesson. It is just some of the idea that come from some people, not all the people in the ministry. And ministry didn't have the such plan to erase a history lesson. He said that about the history lesson is important, one of the most important lesson in saving the knowledge and saving the let's say nationality of the student. So that's why he said that we will not erase the history lesson. So that's why history also will be learned in chemistry, as we know that we learned about the history of the atom before. Now in this lesson we're going to study also about history of the periodic table at this time. Okay, now before we start about the history of periodic table, now I'm going to ask you, do you have any idea about the word periodic table? Have you heard before periodic table? It's about what actually periodic table? Anybody knows? Or any words that describe this periodic table? Yes.
Tell us the number of the matter, maybe.
Number of element, maybe not matter. Numbers of element. Okay, it consists of element. Good. What else? What do you think?
Name of the element, sir.
What?
Name of the
Element
element.
classification.
Name of the element. Good. The name or something we call it is a properties of the element, isn't it? Properties of the element. Good. And then of course we are talking about a table here, so there will be a table, isn't it? Do we have chairs? No. What is in this table? It is the table that has a friend chairs or another table. This table is not chairs table. Yeah, this table is tabel. Yeah, that you use in Excel. That's kind of table. So it's related to the table. We are going to see some of the elements. Actually, it's not some of the elements. All the elements will be in the table, and we are going to learn about the properties of that element according to the tables. As we know that in the tables there will be two things. There will be rows and there will be columns. Like you study in the Excel, when you open the Excel, you're going to see that there are rows and there are columns. So this thing we're going to see here and this predictable things. Okay, let's start with the history. Actually, talking about the elements, we have to go back to very ancient time. As we know that when the study about the atom has started, at the same time, the study about the element is also started. So people start to observe and work on the element. That's some of the elements are already known since a very, very ancient time. For example, hydrogen, carbon, oxygen. Those are very familiar elements that had been known in a very, very ancient time. Even the very old civilization have already know about that material or that element, right? But in the 17th century, people start to work on those known elements. At the time, not many elements have been found, only some of them, and they start to work on that. What they did at the time, they compile all the known element and they try to investigate the properties of the element. And the element that have the same or not the same, let's say similar properties, they group it in one place and they try to observe the similarities between those elements. Okay, one of the scientists that work on this, the first scientist, yeah, in the ancient time, in the 17th century, is Dobrynin. Dobrynin is one of the scientists. This is the man. I show you the picture here. Is the one who starts work on the work experimentally, work scientifically on the elements, and Dobrynin make groups of the element with the similar properties. Yeah, the element that have the similar characteristic at that time. Not many elements, of course, have been known, and Dobrynin group the element that have the similar properties in a groups. And he found some triad. We call it a triad. Triad or triad is called. What do you understand about this word, triads? It is look like which word in English or in Greek? As we know that science is always related with the Greek language. It is related with what? Triad. Anybody know?
No, sir.
It is three. It's written three, triad. So it is like mono D3 in Greek language. It is actually numbers, isn't it? Three. What does mean three in Greek language or in English? In English also we say three. Three means three, ya. Tiga in bahasa Indonesia.
Yeah.
So the brainer at that time he groups the element into three elements. So every three element he group with one. Three element he group with one. Three element he make the groups. And these three elements must have similar properties. That's why the groups consist of three elements that have been mapped by the Dobrynin. We call as a Dobrynin triads. So Dobrynin triads is a group of three elements that have similar properties. Okay. At that time, there are many triads that have been found by Dobrynin. As you can see here, this is some of the example of the triad that have been found by the Dobryniners. Here in my example, we have four triads. The first triad is lithium, sodium, potassium. The second triad, calcium, strontium, barium, and then chlorine, bromine, iron, another triad. And the last triad here, sulfur, selenium, and tellurium. They're all triads, consist of three elements which has the same properties. Okay? And at that time, they already know also the symbol. So this is the symbol of the elements. And Dobrynin, after he compile, make groups the element with the similar properties, and then he order the element in terms of increasing the atomic mass. So this is the atomic mass of each of the element. As you can see here, in one triad, the atomic mass are increasing. This is 6.9, 23, 39. It's increasing, right? This is also increasing, this is increasing, and this is also increasing. So when you see the triads, Dobereiner order the element in terms of increasing the atomic mass from the lower to the higher atomic mass. Okay, is it clear up to here? And after that, the brain find a very unique things, very unique patterns about the triad here. So there is a uniqueness here, and it is a pattern actually that Dobrener found when he make a group of 3 elements with the similar properties. What he found that the atomic mass of the element in the middle, so if you have triad 3 elements, the first element, the middle element, and the element number 3. So you order the element, you put it in terms of increasing the atomic mass from the lower to the higher. He found a very unique thing, a very interesting thing. The atomic mass of the atoms, or actually the atomic mass of the element in the middle is actually the average of the atomic mass of the first and the third element. So for example here, we have one triad consists of lithium, sodium, and potassium. Lithium atomic mass 7, sodium 23, potassium 39. When you see here, sodium is the middle element, lithium the first element, potassium is the third element. When you calculate the atomic mass of the sodium, actually the atomic mass of sodium is the average of the atomic mass of lithium and potassium. As you can hear, 7 plus 39, if you divide by 2 to find the average, you will get 23. And this pattern is not only for one triad. Almost all the triads have the same pattern. Although the number is not exact, the atomic mass number is not very exact, but it is near to the atomic number of the middle element. The second triad, for example, is bromine. As you can see, bromine 80, the atomic mass, the average is 81.25. This is very near. And another triad here, strontium, the atomic mass is 88, and the average atomic mass is 88.5. So actually, it is very, very near. So this pattern is found by Dobrener in Dobrener triad. So it's very interesting things. Is it clear about Dobrener? Do you have any question?
Yes,
No? Can we move? Okay.
yes, sir.
Let's move to the another things. Still, we are talking about the history. The second scientist that we are going to discuss here is one of the scientists that very important in development of periodic table. The name is Newlands. It is Tanah Baru, bukan Kota Baru, Tanah Baru. Newlands, isn't it? But it's not Tanah Baru, of course. It is the name of the guys that study about the periodic table, Newlands. Newlands have one law that he proposed, or he states. The law is called as a law of octaves. So octave is related with the music actually. Now we are going to see what is the connection with this periodic table with the music. It is sound like a music things, octaves, right? So what Newlands do is almost the same like Dobrener's do. Newlands also compile of all the elements that had been found at that time. Newlands' work is in the years 1865. It's still in the 17th century, and at that time only a couple of elements have been found. Here are some of the elements that have been found at that time. And Newlands also ordered the element according to the increasing of atomic mass again. Yeah, increasing of the atomic mass. This is very important, guys. Increasing of atomic mass here. We are talking about atomic mass. Yeah. So here, Newlands order from the lower atomic mass to the higher atomic mass. So hydrogen 1, lithium, and then beryllium, and then boron, carbon, nitrogen, oxygen, so on until iron 56. So this is the order of the element according to the Newlands. Like this, the same like the Dobberinier, Newlands also found a very interesting thing, very unique things in this order. What is unique here in the order made by Newlands? The unique thing here is Newland found that the order of the elements is like an octave in music. Do you know octave in music?
Yes, sir.
Octave means 8, right? In Greek language, octave, it means 8. So like music, it has 8 rhythm. Do, re, mi, fa, sol, la, si. Again,
Do.
the eighth rhythm is back to first rhythm, isn't it? Do, number 1, re, mi, fa, sol, la, si. The number 8 is
Do.
back to number 1. Do again. Do, re, mi, fa, sol, la, si, do. So when you come to the 8th rhythm, you back to the first rhythm actually. So this is the same like octave, the elements, when you order the element from the lower atomic mass to the higher atomic mass, when you have to the eighth element, actually the eighth element turn out to have the similar properties with the first element. So for example here, look at the red dot here. This red dot is showing you the hydrogen, okay? So hydrogen here is the first element. Hydrogen, lithium, beryllium, boron, carbon, nitrogen, oxygen. Oxygen is the 7th element. And we come to the 8th element, which is fluorine. When you see the fluorine, fluorine have a very similar properties with the hydrogen. Okay, when you come to the 8th element, it's very similar to the first element. Okay, so hydrogen on 1, 2, 3, 4, 5, 6, 7, 8. The 8th element is have the similar properties with the first element, and it is repeated, not only one time. It is repeated. Another 8th element also is the same. Let's say that fluorine is element number 1. 1, 2, 3, 4, 5, 6, 7. Number 8 is chlorine, and chlorine also have a very similar properties with the fluorine and with the hydrogen. So each 8th element, yeah, there will be a repeated properties. So that's why this kind of founding found by the by Newlands, it is called as a Newlands Law of octave, because it is the same like octave in music. Do, re, mi, fa, sol, la, si, do. When it is turned to the 8th rhythm, it's going to back to the first rhythm. So it is the same like in the elements that ordered by the Newlands. So when it's come to the 8th element, the 8th element will have the similar properties with the first element. Okay, is it clear? Do you have any question? No? Can we move? Okay, let's move then. Now, the next one is Mendeleev periodic tables. So Mendeleev is the one of the most important person in the development of periodic table. Even though he is called as the father of the periodic table, bapaknya periodic table, the father of periodic table, Dmitry Mendeleev. Actually, it is written like this, Mendeleev, but sometimes it is pronounced as Mendeleev because he came from Russian, so it's coming from Russian language. So it's Mendeleev. Yeah, he found one thing, and that's why it's called as the father of the periodic table. He made a table at that time. This is very special for the Mendeleev. Why he's become the father of the periodic table? Because of the table that he made. So when we came to the Dobereiner and Newlands, they didn't make a table. He just ordered the element according to the increasing of the atomic mass, right? But Mendeleev are special because he made a table. Yeah. So imagine that you have an Excel. So there is a block, right? There is a cell in the Excel, right? There is a place for putting something in the cell. So there is square, block square that you can put something inside. It is called as a cell in Excel. So when you have a table, you will have that one. You will have the cell. In the row, you will have the cell. In the column, also you will have the cell. So this is what Mendeleev did. Mendeleev made a table, and he put all the noun element at that time inside the table. So he put it all the noun element inside the table. Of course, he didn't put the element with no knowledge about putting the element. Yeah. Sorry. So he put the element according to the knowledge about the properties of that element. So if the element have the same properties, so he put it in the same columns, yeah. And from the left to the right in the same row, he puts the element according to the increasing of the atomic mass. So it is the same like Dobereiner and like the Newlands. He also put the elements from the left to the right in terms of increasing of the atomic mass, yeah. And then he put the element in the same column if they have the same properties, okay. And what Dmitry Mendeleev found, he found very interesting thing also, like Dobereiner and Newlands. Mendeleev also found a very interesting thing here. When he put the element according to increasing atomic mass in the table, he found that the properties will be repeated themselves periodically. So the properties will repeat it periodically. What does mean periodically? For example, if you school periodically, what does it mean?
Terjadwal kayak itu loh, ya teratur.
You have the schedule, teratur, right? Periodic means schedule. So, for example, if I'm going to go, I went to market, for example, periodically once a week, for example, in Friday. So it is periodically every Friday I will go to the market because periodically. So is it the same when you put the elements into the table that he made? Mendeleev saw that there is periodicity, yeah. In terms of what? Of course, in terms of properties. It is actually somehow like the Newlands said. Actually, Newlands also said about the periodically, right? When they come to the eighth element, then the eighth element will have the same properties with the first element. So it is like periodically. So Mendeleev also saying the same thing. When you put the element into the table, you will see that there will be a periodic occurring of the properties. So every element will have the same properties periodically in the tables. Okay. So actually, this is the handwriting of the Mendeleev. He at that time he worked on the paper like this. Maybe at that time there is no computer, so he worked on the paper. He wrote by himself, by his hand. And then after that, he made actually a table like this. As you can see here, this is a table that has been made by the Mendeleev. At that time, he made a little bit a complicated table than Dobryner, because we know that Dobryner is very ancient. So at that time, when Dobryner studied about the elements, only some of the elements have been found. As you can see here, the one that have this what we call that one, gridded block like this. If it is gridded block, it is Dobryner's triad. As you can see here, only some of Dobryner triad have been found, but the yellow block here, yellow column or yellow block, it is known to Mendeleev. So Mendeleev have already found many elements than Dobryner. So at that time, the study about the element have been growing compared with the Dobryner's triad times. But still, Mendeleev had some element which is not known. The blue one here, or the purple one, is the unknown element to Mendeleev. As you can see here, the purple one is not known by Mendeleev, but at that time, Mendeleev put this block as blank. Okay? He put this block as a blank because he didn't know the element. So don't see this element. Actually, this element at that time is not known. Ya, elemen yang ini, yang the purple, the one which is in the purple is not known. It is not known. Yeah, it's blank actually. Because at that time, this element have not been found. But Mendeleev put his place already. Walaupun tidak diketahui, although it is not known, but Mendeleev can predict the existence of this element. Yeah, Mendeleev predict the existence of the element. That's why he put blank here. He put blank block here because he know that there will be an element here according to the prediction of the properties. Yeah. So some of the elements have been predicted by the Mendeleev. These are some elements that have been predicted. For example, gallium, guys, scandium, germanium. At that time, it is not found yet. This element is not found yet at Mendeleev years study. When Mendeleev studied, at that years, gallium, scandium, and germanium has not been found. But Mendeleev already predict the existence of that element. He gave the name of that predicted element. For example, for gallium, he put the name Eka aluminium. For scandium, he gave the name Eka boron. For germanium, he gave the name Eka silicon. This Eka means in Greek language, Eka means after. So gallium means after, Eka aluminium means after aluminium. So after aluminium, there will be gallium. When you come to the predict table, gallium here is under aluminium. As you can see here, gallium here is under aluminium. And scandium, Eka boron, after boron. Yeah, scandium is here, it is also after boron. Actually, boron and aluminum is the same group. After boron, he predicts scandium. After aluminum, he predicts gallium. And then another one, Eka silicon. Eka silicon is after silicon. He predicts. And after silicon is actually the germanium. This one. Yeah. After silicon is the germanium. Mendeleev predict the properties. So he predict the properties of that predicted element, Eka aluminum, Eka boron, Eka silicon. And when these elements are found, and then he observed the properties, and he compared the properties of what he predicted already and the properties that the real properties after the element have been found. When there is comparison, the properties between those elements, their properties and the predicted properties and the real properties seems to be similar. So that's why Mendeleev is doing well in predicting the element that have not been found at that time. So he predict according to the similar properties of the element before. That's why he can predict similar properties. So still the Mendeleev table still have a weakness. Why still have a weakness? The mass of the Mendeleev table is not going smoothly. Normally it must be increasing of the atomic mass, but in some of the place it is not increasing the mass, but it is decreasing. I don't know whether I can find the example in here or not.
WRE.
Yes, where?
WRE.
As you can see here, it is decreasing. Yeah, the mass is not smoothly increasing, but it is. There are some of the decreasing. So this is one of the weaknesses of the Mendeleev, and then it's hard to predict. To predict the element is very hard. How to predict the properties of the element, which is unknown, is very hard. Also, the weakness of the Mendeleev. And the hydrogen, in the hydrogen also, he didn't know how to put the hydrogen here, because hydrogen is not the same with the other groups. So hydrogen must be put in different ways. It is anomaly. So that's why anomaly of hydrogen. And actually these weaknesses and then come up, or it is have been corrected by the scientist named Henry Moseley. He thought that you mustn't put the element according to the atomic mass, but you have to order the element according to the atomic number. At that time, you will see that there will be no weaknesses in terms of atomic mass. So you have to change the atomic mass into atomic number. It is what Henry Moseley said. So that's Henry Moseley that become the modern periodic table that we use today. We have to finish here. We continue in the afternoon in the WhatsApp. I'm sorry, I'm going to repeat again about the Henry Moseley on the Thursday. We run out of time. See you next lesson in afternoon, inshallah, in the WhatsApp. That's enough.